In this video, I'll be covering problem number 15, where we solve by using U substitution. So for problem A, we should recognize that we can use U substitution because we have three terms where the last is a constant and the second term has an exponent that is half the value of the first exponent. So 1/3 is half of 2/3. If that's the case, then we can define a U value as Z to the 1/3 power. Then we simply take the coefficients of our terms here in our equation and write it as a quadratic equation. So that would be U squared minus 1U minus 6 equals 0. At this point, we should recognize this as an easily factorable quadratic equation. U squared is the product of U and U. We want to find two factors of 6 that combine to give us -1. We know those factors of -6, one must be positive and one must be negative. If I use the factors 3 and 2, where 3 is negative and 2 is positive, then -3 plus 2 will equal -1, while -3 times +2 will give us -6, so it's correctly factored. If you're unsure if something's factored correctly, by the way, right here on your home screen, you could type in your equation using x squared minus x minus 6, hit enter, then type in your factors. If you have factored correctly, you'll get the same value, okay? So another quick way you can check mid-progress to see how you're doing. We set each of these factors equal to 0 and solve. So we get a U value of +3 and a U value of -2. You're not through. At this point, you need to solve for Z, and we know that U is Z to the 1/3 power. So we go back in and substitute at this point. Well, remember, this is the same thing as the cube root, but if we want to get Z by itself, we simply need to raise each side to the power that is the reciprocal of 1/3. 1/3, its reciprocal is 3/1. We just flip it. So 3/1 is 3, so I'm going to raise both sides to the 3rd power. I'm going to cube them. Recognize that because it's over 1, 3 cancels and 1 cancels, leaving just Z. And 3 cubed has a value of 27. Same here. And -2 cubed is -8. That's -2 times -2 times -2. So let's check and see if it works. So all we have to do is take 27, store that as our x value, then evaluate our original function. X to the 2/3 power minus x to the 1/3 power minus 6. If 27 is the correct value, it will come out to equal 0. And it does, so 27 is a good answer. Next, I'm going to type -8 and store that as my new x value. To avoid having to duplicate what I just typed here, I'm going to hit second enter, and it brings up what I had last. I'm going to hit second enter again, and it brings up this value. But now it will store my new x value of -8. If it equals 0, it also is a solution. And it is. So that tells me that both of these are in fact solutions. Next, for B, I notice that I have the square root of x here in my middle term. That's the same thing. Remember, square root of x is the same thing as x to the 1/2 power. I'm going to let that be my U value. But I know that this works because the power 1/2 is half of 1. Okay? So at this point, I'm going to rewrite it as a quadratic equation rather. We're using my U's. Don't make this difficult. Just simply write quadratic term, linear term, constant, where my coefficients are the same. At this point, I should recognize this as a factorable quadratic equation. 2U and U. If I use 4 here and subtract 1, you get 8 minus 1 to equal 7. Okay, if you have any trouble with factoring, please search YouTube for factoring trinomials by trial and error. At this point, we set each factor equal to 0 and solve. We would add 1, divide by 2. Here, subtract 4, and I get these two values. I prefer substituting the square root of x over x to the 1/2. Some of you may have a preference, or maybe you don't care, but remember what I said in class, though. You cannot have the square root of a number equal -4. It is simply not possible. So this will not be a solution. However, if you were to continue on and square both sides and get that x equals 16, when you test your value, it won't work. So I'll show you that in a minute. To undo a square root, like I said, we square both sides. This is 1/2 times 1/2, which is 1/4. Now to check our answers, I'm going to type in 1 divided by 4, store as x, enter, and then type my equation in, 2x plus 7 square roots of x. Going to need to hit that right arrow to come out of the radical there, and hit -4. If 1/4 is a good answer, my answer will come out to equal 0, and it does, so it's good. Now, say you forgot that and you checked, you're going through the process and you want to check 16. Second enter, so I don't have to type it again. And notice it equaled 56. It did not equal 0. That tells you that that would not be a good solution, so the only correct solution is 1/4. Okay? Next, for C, it appears that this would work because 4 is half of 8, so I'm going to let u equal x to the 4th power. And my coefficients are 1, -17, and 72. So I'm going to make this x squared, 1x squared, or u squared rather, I'm sorry. 1u squared minus 17u plus 72. When you're thinking about factors of 72, remember 8 times 9 gives you 72. And we can add 8 plus 9 to get 17. So that should work out. So I'm going to need negative, because the only way I can multiply and get a -72 is multiply 2 negatives or 2 positives. But I need to combine these two terms here to get -17. So I'm going to try 8 and 9. Okay, 8 times 9, -8 times -9 is 72. -8 minus 9 is -17. Set them equal to 0 and solve. So u equals 8 and u equals 9. But now I have to go back and substitute x to the 4th. Equals, oops, sorry about that, equals 9. This is x to the 4th equals 8, so you actually have to take the 4th root of both sides. Now, in our calculator, if we type in 4th root, you get where you can see it, you would go to 4, math, and have to choose option 5. This will make it do 4th root. Well, if I do 4th root of 8, I'm going to get an irrational number. I do not want you to list an irrational number as a solution. If we did break this down, all we would get is 2 times 2 times 2, which is not enough to form a group. So I would want you to leave your answer as the exact value, the 4th root of 8. To undo x to the 4th here again, 4th root. Clearly, this should not work. If I do this again, but change that to a 9, we again will get an irrational value. So please leave your answer as the 4th root of 9. And let's see. Because we took an even root, we're going to need plus or minus. Sorry about that. Plus or minus. Plus or minus. Okay? So remember, we should be getting 4 solutions. But what this means is we are going to have 8 solutions. You can see we have 4, but what should happen is they should bounce off at these values. So notice your values are about 1.7 and 1, well, they're kind of close, 1.68 plus or minus, and plus or minus 1.7. So when we go to look at the graph or store the values, it should work. So I'm going to go back here to this 4th root of 8. And I'm going to store my values as x. Okay? Now when I go to answer my equation, or type in my equation, x to the 8th power minus 17x to the 4th power, oops, plus 72. If my answer is correct, then I'll get 0. And I do. Now, also that means that the opposite of the fourth root of 8, so negative fourth root of 8, oops, I didn't mean to do it that way, negative for math, negative fourth root of 8, I can store that as x, store as x, enter, hit second, enter, till I get to my equation. If that value works, I'll get 0, 2. So, of course, we would follow suit with the plus or minus the fourth root of 9, but I want to show you on your graph what that means because it's going to affect your multiplicity. So that means if we type in our original function, x to the 8th power minus 17x to the 4th plus 72, we can see it bounces here, and it's really hard to tell. Let's see what's going on. Let's zoom in here. Zoom to enter. And I'm going to go over here and zoom in again when it's done. Zoom to enter. So why am I doing this again? Because we have two x values that are extremely close to one another, okay? So make sure when you list your answers here that you do plus or minus the fourth root of 8 and plus or minus the fourth root of 9. If I go back to zoom 6, I can see that the same thing happens on the opposite side. Therefore, the plus or minus makes sense, okay? All right, and that's your last solution for problem 15. Good luck on your test.